Hello, Algebra 2 students. We are going to dive right into lesson number 2, which utilizes the 7.1.7 guided note sheet. So please either print that off or go ahead and get out a blank sheet of paper and title it 7.1.7. And you can always pause the video if you need to copy down specific parts of the problem for the purpose of your notes. So we are going to start with two warm-up problems, 90 and 91. That you can go ahead and try on your own. So I really do encourage you to pause the video, read through 90 and 91, try them on your own, and then start the video again, and I will walk you through it. And that's kind of like checks for understanding when I'm not standing over your shoulder, making sure you're doing something correctly. So it says on 90, calculate the value of sine of 4 pi. Give an exact measurement if possible. So now we are having to visualize where this is on the unit circle. Sure, you could just go to your unit circle and look for 4 pi over 3, but I really encourage you to kind of follow along how we can do this quickly. So if I envision my unit circle, okay, I know that the numerator number is larger than the denominator, so I know that at this point, this is 3 pi over 3. Remember we said when it's the same number, that's really just like a semicircle. So then 4 pi over 3 is the same thing if I like to think in terms of sixths, because there's 2 sixths in each quadrant. 4 pi over 3 is the same thing as 8 pi over 6. So some people are going to understand that the pi over 3s are closer to the y-axis, okay, but other people are going to prefer to think of those sixths, okay, so this would be 7 pi over 6, and this would be 8 pi over 6, which is what we want to focus on, okay, so with our focus then, what you're thinking about is because this is 4 pi over 3, okay, and just reiterating, that is the measure of this angle right here. Okay, so it's definitely greater than 180 because we always measure angles in this form. We're thinking about what are the coordinates of this point. Well, because it's related to those 30, 60, 90 triangles, we're thinking about long side and short side starting from the origin. So if I start from the origin to get to 4 pi over 3, I'm going to go short, then long. Okay, so my short side always is represented by 1/2, and then my long side is root 3 over 2, and because we are in the third quadrant, we know that both sine and cosine are going to be negative, so tack a negative on both of those. But if we go back up to the problem, it wants the sine, so do not give me the entire coordinate pair. We need to make sure to write out our answer. The sine of the angle in radians, 4 pi over 3, is the y value, because c comes before s, x comes before y, so negative root 3 over 2 is your answer. That would be what I'm looking for on a worksheet that asks this question. Now, okay, how can you check your answer? You can always go to your calculator and make sure you're in radian mode and type in sine of, let's see, I need to get into radian mode. So sine of 4 pi over 3, put that 4 pi in parentheses. If you're not using the fraction button, you have to. Okay, and then go ahead and type in negative root 3 over 2. Okay, and you can see that both of those give the same decimal, but because it wanted exact, we couldn't really rely on our graphing calculator because your graphing calculator will not give you this even if you try to convert it back to fraction mode. So that's how we require you to memorize that unit circle. Okay, now moving on to 91. Hopefully you tried this on your own. If not, please do so. It says find the exact values of the angles. So our answer is not going to be like root 2 over 2 or root 3 over 2. It's going to be an angle that are solutions to the equation sine of the angle equals 0.5. Well, how can I immediately write this differently so that it maybe looks more familiar from what we did in the last lesson? Sine of what angle equals 1/2? we are literally thinking about our unit circle, and we're thinking what angles, okay, are going to have a sine of 1/2. Well, we know that what quadrants, first of all, have a positive sine. Well, sine deals with y, so we know that quadrant 1 and quadrant 2 both have positive y values. Okay, so now we're thinking about the y value being the shorter side of the triangle, because 1/2 is the shorter side on those special angles. Okay, so I can envision the triangle here, and I can envision the triangle here because the y value is that shorter side. So when I think about going around my unit circle, I know, okay, that these points have to be pi over 6s because they're closer to the x-axis rather than the y-axis. So we have pi over 6 is this angle, and then this would be 5 pi over 6. Now, okay, let's look at our unit circle. Well, let's write out the claim. We are claiming that the theta that would make this true would be pi over 6, because it says give your answer in radians, so you do not want to say 30 degrees and 150, or 5 pi over 6. A lot of times in trigonometry, you get two answers because of that symmetry. Now, if you type this into your calculator, why don't you go ahead right now, be in radian mode, and do sine of pi over 6. And what do you get? You get 0.5. And then go ahead and do sine of 5 pi over 6. You're going to get 0.5. Now, on your unit circle, always have this handy in trig lessons. We can see that at pi over 6, okay, which is right here, okay, we have the sine value is 1/2. So we could have also looked at our unit circle, and the sine value here is 1/2, but not on every assessment can you use a copy of the unit circle. So that's why I'm stressing how would we do these from scratch. All right, so moving along. Okay, it says, in the past several lessons, including those before spring break, we have used our understanding of sine and cosine ratios to develop and interpret the function s of theta equals sine theta, c of theta equals cosine theta. We utilized our knowledge from geometry with what we call right triangle trig. In this lesson, we are going to use our understanding to start exploring the tangent ratio. Remember, SOHCAHTOA. TOA. So we've been working with SO and CA, but now we're going to look at that idea of tangent. So Jamal, this is problem 99, was working on his homework when he had a brilliant realization. He was drawing a triangle in the unit circle to estimate the sine of pi over 10. Now, pi over 10 is not a special triangle, so we don't have anything memorized, but we could estimate. Okay. So let's go ahead and draw that on our note sheet here. Sorry, I'm going to kind of zoom in. If we draw a unit circle, okay, and we're thinking about where would pi over 10 be? Well, pi over 10 is even smaller than pi over 6. Okay, because we're dividing pi into 10 pieces, so pi over 10 is less than pi over 6, which pi over 6 is the smallest angle that we know. Okay, so pi over 10, it's going to be hard to draw it, okay, but is going to be a very little sliver of the start of the unit circle. Okay, so this right here would be our pi over 10. So it says, how could we express the slope of the radius in terms of sine and cosine? Okay, well, we know that if we look at the coordinate point on the unit circle, right here, okay, what are the coordinates going to be? The coordinates are going to be whatever the cosine of pi over 10 is, comma, whatever the sine of pi over 10 is, because as a review, the cosine in the unit circle gives us the x value on the circle, and then the sine of the angle gives us the y value. So when we find slope of a line, what do? We know that slope is change in y over change in x. This is some Algebra 1 review. So if we utilize what I just wrote down, okay, we see that slope in this case, what is the y value? If we start from the origin, the y value is going to be identical to the sine of pi over 10 over what is the x value. Because we're starting from the origin, we can use the cosine of pi over 10. Okay? Now, if we look at this from a different perspective, it says, is there any other way that we could use trig if we're going to talk about the slope of the line? Okay, hang with me. This is kind of guiding to the key idea that I will make sure to stress. Okay, if I redraw that little triangle, so pretend this is the origin, okay, and this is our radius, and if we go, this is our x value, and we have our y value. Okay, we said that the length of the base of the triangle is the cosine of pi over 10. And we said the height is the sine of pi over 10. Okay, and we're really kind of looking at how can we express the slope of the hypotenuse. Okay, well, if we're looking at this reference angle called theta, when I think back to geometry, I think that I can look at the sine of pi over 10 as being like the opposite side compared to theta. I think I can look at the cosine as being the adjacent side compared to theta. So what do we know about opposite and adjacent? That has everything to do with TOA. Tangent equals opposite over adjacent. So, what is the opposite side? We're going to write tangent of our reference angle, which in this case is pi over 10. So I guess I can go ahead and replace that with pi over 10 because that is our example. So let's go ahead and note that theta is pi over 10 in this case. So the tangent of pi over 10 equals the opposite side, which we said is the length of sine pi over 10, which is normally what we would call y, over the x value, which is cosine pi over 10. And that is the key idea, okay? So we are going to do some calculations, and what I'd like you to do is I would like you to find the sine of pi over 10 on your calculator. That is like 0.309. I'm going to write these off to the side just to show you that it all works. So we have like about 0.309. And then we have cosine of pi over 10. I want you to go ahead and calculate that, 0.951. Okay, and I want you to divide those. So if you have a calculator that you can go up and grab each value, that would be the best because we want to minimize rounding. And when we do the division, okay, you get approximately 0.325 would be what we'd consider kind of the slope of the line, or we're claiming that that's approximately equivalent to the tangent of pi over 10. Okay, now I want you to utilize your calculator in radian mode, and I want you to find the tangent button, and I want you to type in pi over 10. So tangent of pi over 10, please do this with me. And when you look, what do you get? You get 0.3249, which is exactly what we got here. So that was kind of the look behind the scenes and how this idea comes about. But now we're going to look a little more straightforward because we have just discovered, I'm going to write it down and then we'll address it in a few minutes after we prep our activity sheet. we have just discovered that the tangent of an angle is equivalent to whatever the sine of the angle is over the cosine of the angle. Okay, now people are going to get mixed up because I've been talking so much about C comes before S, but if you notice in tangent, okay, S is over C. What are we going to relate this to? We are going to say think slope. What is slope? Change in y over change in x. So if you've memorized that sine has everything to do with y and cosine has everything to do with x, you are going to be okay. So now to really work and dive into this idea of the tangent function, it says we are going to use our unit circle that we were prepared in lesson 716. So that's what we did in lesson number 1 yesterday, and determine the exact value of the sine and cosine for each angle measure listed. Then list them on the table on the next page or make a table on a blank sheet of paper, and you can see that they've been completed for you for 0 and pi over 6. So right now I want you to go to the third page of the note sheet, whether that's on your computer or print it off, and you need to pause the video and try to fill it out on your own. Okay, and then you can always fast forward through me if that was a breeze. Okay, so don't think that you have to sit here and listen to me talk the whole time if you don't need to. Okay, so I'm going to scroll down and do exactly what they said, and you're doing the same. Okay, so the cosine of pi over 4 is root 2 over 2, and you can always be using your unit circle, root 2 over 2. We have the cosine of pi over 3, that would be short, which is 1/2, and then we have root 3 over 2. Pi over 2 is going to be over 0, up 1. Then we have 2 pi over 3 is going to be 1/2. You're going to see symmetry happening. Root 3 over 2, but then I'm thinking, okay, I have to go negative in the x direction. Okay, then we're going to come across 3 pi over 4, and then that is going to be root 2 over 2, root 2 over 2. And again, we have the negative in the x. Then we have 5 pi over 6, which the cosine is going to be root 3 over 2, negative, and then 1/2 is going to be the sine. Then we get to pi, which is -1 in the x direction, 0 in the y direction. Continuing on, the next thing that we would have would be 7 pi over 6, which is going to have both negative, so we're going to go long in the x direction, negative root 3 over 2, and then we have -1/2. Okay, then we have 5 pi over 4, that middle line in the third quadrant, so negative root 2 over 2, negative root 2 over 2. Then we have 8 pi over 6, which would be 4 pi over 3. Okay, then we're going to have short first and long second. Okay, and then we have, yay, we made it to 3 pi over 2, which is below on the y-axis, so we go over 0, down -1. And then we can go ahead and keep going. So we're in the fourth quadrant now. We are going to have, let's see, 10 pi over 6, which is 5 pi over 3. So we're going to go short first, which is positive in the x direction, and then long, which is going to be negative down below the x-axis. Then we have 7 pi over 4. So we're going to do root 2 over 2. I love those pi over 4s because they're the same sine and cosine. but I see that my sign is going to still be negative. Then I have 11 pi over 6. This is great for practicing our memorization. We're going to go long and then short to get there. I always have to envision those triangles, negative in the sign. And then finally we made it to 12 pi over 6, or 2 pi, which is going over 1 up 0. Okay, so we did what they asked us for number 1, okay, which was to simply fill out the sine and the cosine. Now we are going to, let's see here, use the unit circle to complete the remaining values of theta. We did that. So now we are moving on to this idea of tangent. Where's my marker? Come on. Okay, there it is. So it says that we want to start finding exact values of tangent. It says, remember that a fraction divided by a fraction is the same thing as multiplying by the reciprocal of that second fraction. We did this when we were dividing rational functions back in first semester. Then use your calculator to turn the exact value into a decimal. Okay, so what we are going to do is we can go ahead and scroll down and see the table. So they have showed us the first two. Remember, tangent, you want to write this on your note sheet if you didn't copy it off. Tangent is equal to the sine of theta over the cosine of theta. So we have to divide the let's see, sine of theta, so yellow, over the cosine of theta, red. So we have to do that on every problem, okay? So let's go ahead and see that on the pi over 6, they took 1/2, which is the sine of theta, and they divided it by root 3 over 2. Now they're showing the multiplication by the reciprocal. So what is the reciprocal of root 3 over 2? It is 2 over root 3. Now how do you multiply fractions? You multiply straight across the top, and then you multiply straight across the bottoms. Okay, now, if you're good, though, at multiplying fractions and you remember back, we see, okay, that the 2's cancel out. Whenever you have a number on the top and a number on the bottom and you're multiplying, that's like the great one. So we have 1 over root 3. Now, how did they get 1 over, or to root 3 over 3? Remember before break, we talked about rationalizing the denominator. So if we multiply the top and the bottom by root 3, what is root 3 times root 3? Well, these pop out a 3, and then what's 1 times root 3? Root 3. Okay, so the best answer that we are going to give is going to be the rationalized value. Okay, so I'm going to take you through some of these, and you can pause it if you want to try on your own. Please be my guest, and we'll see how it goes from there. Okay, so let's go ahead and try pi over 4. Well, I like pi over 4 because what is the sine? The sine is root 2 over 2. Okay, divided by, what is the cosine? Root 2 over 2. So that's equivalent to taking your first fraction and multiplying by the reciprocal. What's the reciprocal? It's going to be 2 over root 2. So I love this because we can see that our 2's cancel out, our root 2's cancel out. So what are we left with? We're left with 1. So the tangent of pi over 4, I'm not going to write this every time, the tangent of pi over 4 is 1. Okay, that's kind of like the fact that we're coming to. So tangent takes an extra calculation. So let's try pi over 3. Okay, so for this one, what is our sign? We do root 3 over 2 divided by 1/2. But division of fractions means we have to multiply by the reciprocal. So then we have 2 over 2, those cross out. So we get root 3 over 1. Yes, I love when the root is not in the denominator. What's anything divided by 1? Just itself. Okay, so that is the tangent of pi over 3. Keep going. Okay, now here we see that the the sine is 1, and we're dividing that by the cosine. Well, go ahead and do 1 divided by 0. What do you get? You cannot divide by 0. So the tangent of pi over 2 is undefined. Don't tell me it's 0. That is incorrect. The tangent of what angle is 0? The tangent of 0 degrees or radians is 0, but the tangent of pi over 2 is undefined. Okay? Again, you can pause me and just go through this. That is fine. Or you can stick with me if it helps you. So we are doing now root 3 over 2 is our sine. We are dividing that by negative 1/2. What is a positive divided by a negative? We know our answer is going to be negative. So from here we have root 3 over 2 times negative 2 over 1. You can keep that negative on the top. It doesn't really matter. Now be careful when you cross things out. So sure, we can cross out the negative or the 2's, but that negative still has to stay put. So we get negative root 3 over 1. So the tangent of 2 pi over 3 is negative root 3. Okay, now hopefully you can envision when we have those pi over 4's what's going to happen now. Okay, but we are going to take root 2 divided by 2, and we're going to divide that by negative root 2 divided by 2. Well, what's anything divided by itself? It's 1, but what's anything divided by the opposite of itself? It's negative 1. Okay, so use those basic math facts to help you kind of expedite the process for some of these. For 5 pi over 6, we have 1/2 divided by negative root 3 over 2. When I have division of fractions, I am going to multiply by the reciprocal of the second fraction, but you can keep that negative on top. Okay, so then from here, I have my 2's that cancel out, but I have to keep the negative. Negative root 3 is on the bottom. So this is like the example they gave us where we need to rationalize. You have to, okay? That's just kind of the rule of thumb in math. So to rationalize, you always multiply by the root that is in the denominator. So if I look at this, I have negative root 3 over what's root 3 times root 3? 3. So negative root 3 over 3 is the tangent of 5 pi over 6. Okay, so if we scroll up, I think that's what we had gotten for pi over 6. So please make note of all of the symmetry that is occurring. Okay, we are still recording. Sorry, I was scared that I had turned it off. Okay, so we are going to continue on. And where is my pen? Okay, let's look for some symmetry here, though. So now we are at pi, and we can see that this one, we might just need to do the division. So we have 0 divided by negative 1. What's 0 divided by anything? 0. So this is, again, a case where the tangent of certain angles is going to be 0, but then other times the tangent is going to be undefined. Now, can we make a guess about what the tangent of 7 pi over 6, 5 pi over 4, and 4 pi over 3 are going to be? Okay, well, we can see that if we are taking negative divided by a negative, all of these right here the tangent is going to be positive. Okay, if we want to backtrack, we saw that when we were taking a negative divided by a positive, okay, here we saw that the tangent was going to be negative. But we know that due to the symmetry, we're going to have some of these values be the same. So if we look at 7 pi over 6, we know that this box right here has the same values as this box right here in terms of sine and cosine, but just the sign, when I say sign, in this case I'm meaning positive, negative, is just slightly different. So what was the tangent of 5 pi over 6? It was root 3 over 3. Okay, but it was negative in the second quadrant, but now that we're in the third quadrant, if I'm taking a negative divided by a negative, it's going to result in a positive. Okay, now can you guess what the 5 pi over 4 is going to be? If it was negative 1 in that second quadrant, then what is it going to be in the third quadrant? Not negative 1, it's going to be positive 1. Okay, and then finally, you can look also at your unit circle, but we can go ahead and take a guess that 4 pi over 3, I see 1/2 in root 3 over 2, and then I see 1/2 root 3 over 2. Okay, we can guess that the tangent is going to be root 3 without a negative. So that is how, after you fill out kind of the first quadrant and second quadrant, the tangent is going to be the reflection. Now we can quickly go ahead and think about for the 270 degrees, which is 3 pi over 2, we have negative 1 over 0. What's negative 1 divided by 0? We cannot divide by 0, so it is undefined. Okay, and then we're going to keep going and think about, okay, in the fourth quadrant, okay, if we have a negative divided by a positive, that's representing the tangent. And a negative divided by a positive is going to be negative. So again, okay, we can go through all the math, but we could also just look up at our table and we can think about, okay, 5 pi over 3 has 1/2 as the cosine. Let me look up and see what has 1/2 as the cosine, which is right here. So I can see that it's going to be root 3, but we've established that the tangent has to be negative due to arithmetic of a positive and a negative. And then pi over 4, again, any pi over 4 is going to have the tangent of 1, but this has to be negative. And then looking up for the value that has root 3 over 2, I can see that that tangent is going to be root 3 over 3. But if I take a negative divided by a positive, the negative has to go out front. And then finally, I'm at my end of the circle, so 0 divided by 1 is 0. So we have just filled out the entire table with the values of tangent. Okay, so we can box these off. These are the tangents of all of the memorized angles, or we call them special angles, on the unit circle. So I think we're going to leave it at that today. If you could go ahead and just type in the boxed values to get the decimal approximations in this final column. Okay, I will go ahead and finish it when I'm done with this video, and I will post the teacher copy of these notes like I always do in lesson number 2, so you can check your answers so that your table is complete, but I don't think it's necessary to stay on and do this alongside of you. So, at this point, make sure your notes, we're going to name this 717 Day 1 because we are going to continue with 717 on Lesson 3. But for now, I'm going to leave you with this and go ahead and make sure to do the review preview that is attached on Google Classroom to Lesson 2. And we will just keep going with it tomorrow. Good job today.